So far, we have seen Nichol stability criterion and sums on that. Today, let us see relative stability using Nichol criterion and M circles. M and constant M and N circles. Similarly, we can find the N circles. What is angle of G of J, angle of T of J omega, closed loop angle equal to angle of x plus jy upon 1 plus x plus jy. This is equal to tan inverse of imaginary part by real part minus y plus, this is numerator, that's why plus, minus tan inverse of y upon 1 plus x. So let us call this as n or theta equal to theta equal to tan inverse of y by x minus tan inverse of y by 1 plus x. Take tan on both sides. Tan theta equal to tan inverse of y by x minus tan inverse of y by 1 plus x. If you take tan on right hand side, you will get tan of tan inverse of y by x, that is y by x, y by x minus tan of tan inverse of y by 1 plus x, that is y by 1 plus x upon 1 plus tan A tan B, that is y by x multiplied by y by 1 plus x. Let us call this tan theta as n. If we vary k, the angle also, if we vary this omega, the angle also will vary. N also will vary. For different values of n, you will get different circles, that is called the n circles, that we are going to prove that the right hand side forms a, this equation forms a circle. So what you will get is n equal to, take LCM. If you take LCM, y multiplied by 1 plus x minus y multiplied by x upon x multiplied by 1 plus x whole divided by, this is numerator. Denominator also you will get x multiplied by 1 plus x. If you take LCM, x multiplied by 1 plus x plus y square. So this x and x, this 1 plus x getting cancelled. Therefore, n equal to y plus xy minus xy whole divided by x plus x square plus y square. So this xy also getting cancelled. Therefore, y by x plus x square plus y square. Two n square. So bring this n to the right hand side, this to the left hand side. What you will get is x plus x square plus y square equal to y by n. Here x square plus y square is there. That's why it can be proved as a circle, equation of circle. Add on both sides 1 by 4 plus 1 by 4 and 1 by 2n whole square and 1 by 2n whole square. Add on both sides. So we can write x square is there, x is there, and 1 by 4. If we combine x square and this 1 by 4, this 1 by 4 together, if you combine, what you will get is x plus 1 by 2 whole square. What is x plus 1 by 2 whole square? X square plus 2x by 2, that is x plus 1 by 4. The remaining is, you can bring this y by n also to the left hand side. You can bring that y by n also to the left hand side, minus y by n, and this becomes equal to you y by n also to the left hand side to convert this into equation. That's all. So if you can write y minus 1 by 2n whole square, what you will get? Y square you will get. 1 by 2n square you will get. If you multiply these two with 2, you will get y by minus y by n also you get. So this is left hand side equal to right hand side is 1 by 4 plus 1 by 2n whole square. So it is equation of circle with center. Its center is minus 1 by 2, comma, minus 1 by 2n plus 1 by 2n is the center, and its radius is equal to square root of 1 by 4 plus 1 by 2n whole square. That is radius. Center is minus 1 by 2, comma, plus 1 by 2n is the center. What is the radius? Radius equal to square root of 1 by 4 plus 1 by 2n whole square. That is radius. This equation is always satisfied when x equal to minus 1, y equal to 0. If we substitute x equal to minus 1 plus 1 by 2 equal to minus 1 by 2 whole square is 1 by 4. If you put y equal to 0, you will get 1 by 2n whole square. Right hand side is coming. Therefore, always this point is satisfied by this circle equation. Therefore, all circles will pass through minus 1, comma 0. All circles will pass through minus 1, comma 0. That is one point. Another point is, when x equal to 0, always you will get 1 by 4. When x equal to 0, you will get always 1 by 4 you will get. Similarly, y equal to 0, you will get always the right hand side. This point also always satisfied. Therefore, all circles will pass through 0, comma 0. So all n circles, if you vary omega, you will get infinite. If you vary omega from 0 to infinity, you will get infinite number of angles. Infinite number of angles. That is infinite number of n you will get. So you will get n circles. That n circles, all infinite n circles will pass through minus 1, comma 0 and 0, comma 0. That is this. So always it pass through minus 1, comma 0. Always. This n circle always pass through minus 1, comma 0. These are called set of constant n circle. For each circle, n is constant. That's why it is called constant n circle. This is also called constant n circle. This is n1 circle. This is n2. That's all. Different value of n. The same way, here also the m circle also constant m circle. This in the entire circle, the value of m is constant. The value of m is constant. Here, the value of m is 1.35, constant everywhere. The m value, that is magnitude, is constant. Here, everywhere, the phase is constant. The angle is constant. Here, angle is constant. angle constant. That is called the n circle. If magnitude is constant, m circle. These m and circles are very useful to find the frequency domain specifications. That is called a Nichol's chart. Nichol's chart. But once you got m and n circles, if you plot them in decibel scale, here the m is in linear scale. M is in linear scale. Linear scale. If you take 20 log m, then it is in decibel scale. Take 20 log m for different m. Take different m, take 20 log m and plot on a graph sheet. And similarly, angle in degree. Take angles, n circles in degree. N in degree. That is n equal to what? Tan theta. So tan inverse of n, if you find and plot on a graph sheet, that is called a Nichol's chart. What is Nichol's chart? Nichol's chart is constant m and n circles. Constant m and circles are called a Nichol's chart, but constant m's are in decibel scale and n's are in degrees, not tan theta.